So one of the last topics of the year that we're going to cover is called systems of nonlinear equations. If you think back to when we learned about systems of equations and when you learned about just regular systems of equations in Algebra 1 and earlier in this class, what we did is we had like a line that would go like this and like a line that would go like this. And where did we find the solution to a system that looks like that? Where they cross, in the middle, right? Okay, cool. But that was a system of linear equations because they were both lines. This time, we're going to have nonlinear systems. What do you think is an example of something that is nonlinear? The quadratic. The quadratic is a curve. It is a parabola. That is something that is nonlinear. So an example of what a system of nonlinear equations is going to look like is this right here, where this first equation, well, that's a quadratic, which means it's going to show up something like this. And this second equation, since there's no squared term, that's just a linear equation, which means it's going to show up something like this. We're going to be looking for now, not just where two lines cross, but where the curve and the linear equation will cross. So it's the same concept, like literally where do they cross, but you're going to have one of them that's a quadratic and one of them that's a linear. So the types of solutions you may have for this sort of system looks like this. How many solutions are there for this first system? 2, because how many times does the line cross the curve? 2, so we have 2 solutions. In that second system there, how many times does the line cross the curve? 1, so we only have 1 solution there. This is all kind of sounding familiar, correct? What about this last one? How many times does the line cross the curve? No, so it has no solution. Now, we don't have to do anything with imaginary solutions in this because that's not what we're dealing with. We're not finding the solutions to a quadratic. We're finding the solutions to a system. Same vocabulary word, but different meaning. So we can have 2 solutions where the graph crosses twice. We can have 1 solution where it crosses 1 time. We can have no solutions where it doesn't cross at all. Those are kind of our options for types of answers, but not necessarily how we would answer the actual question. The way we would answer the actual question is by actually finding the coordinate point where they cross. So I have the calculator steps here written on your screen. We're going to use the calculator for this lesson, not Desmos. When you go home, obviously, Desmos will be very easy to use since you know how to use it, but we're going to practice using the calculator. So to solve the following nonlinear systems by graphing, I'll read through the steps with you and then I will do the steps. Number 1, we're going to type the equations into y1. So we're going to end up with an equation in y1 and an equation in y2. Then we're going to press the following buttons. These should be your favorite buttons today. Second trace 5. Second trace 5 are going to be your favorite buttons today because they're going to help you find the intersection. That's what the option 5 is on the trace screen. Once we have done that, we'll have a picture that we're looking at. We're going to move the cursor close to the first point and then press enter, enter, enter. And then we'll have to repeat all of the second trace 5 buttons and move the arrow to the second point and press enter another 3 times. Now this makes no sense until we actually try it. So let's try this together. In your calculator, I would like for you to type both in problem number 1, the first equation and that second equation. We're going to take up 2 lines of our calculator doing this, and I will show you on the screen what I mean. If you're watching the video online, I know I can't show you the screen, so just follow the steps that are listed there. So we have our calculator. We're going to go to the gray buttons for the graph. We're pressing y equals. Which one are we pressing? Great. If there is anything typed there, you're going to want to clear it out. Probably want to clear your calculator every time you pick it up. So we go to that y equals button up at the top of the screen, and we're going to type in what we see. We see x squared minus 4x minus 1. Remember 2 things, that the x button you want to use is here next to alpha. That's the button you use for x. And when we go to the second equation, negative 4x minus 1. Great. Now make sure you know the difference between minus and negative. This first thing right here, that should be a negative sign, and this one should be a minus. That's the difference. Okay, great. All we want to see is what this graph looks like, what this system looks like. Here's what mine looks like. Is that what yours looks like? So we've got it typed in. After we do that, what we're going to do is we're going to press second, which is the blue button. The button called trace that's up in the window. So trace is up here in the gray buttons. It's your calculate screen. The fifth option says intersect because we are looking to see where these two lines intersect. So you select option 5. And then we follow the instructions on the screen. We're going to move the cursor close to the first coordinate point. Do you see how this is covering that first coordinate point? Ish. It's close to it, right? As long as it's close, that's fine. If your little cursor, I like to call it a turtle because I don't know why, but it looks like a turtle to me. If your turtle's all the way over here, is it close to the coordinate point? No, so you would move the little turtle close to the coordinate point. As long as it's near it, we're in good shape. Then we press enter 3 times. Enter, enter, enter. It's going to give you intersection of 0, negative 1. So like literally, that's it. 0, negative 1. That's the place where they cross. Does this system cross anywhere else? No, so we only needed to find one of them. We're literally done with this problem. That's it. Can we do another one? Yeah, all right, let's do one more. So we're going to go back to y equals. We're going to clear out the system we had there because we don't want that system anymore. We're going to go to the next one. The next one says parentheses, x minus 2, close parentheses, squared. I type it in exactly as I see it. The next line, I have a fraction, so I make it fancy. Alpha trace, or alpha y equals enter. 1/4 x squared plus 1/2. Once you get all of that typed in, you press graph and look at it.
Wait, how do we?
When we press graph on this one, how many solutions should I be finding? 2, because the graph looks like this, that we have a curve and then we have a line crossing it. It crosses it 2 times. That means we're looking for 2 solutions. So we're going to have to repeat these steps twice. We press second, trace, 5. Now I'm going to move my little turtle close to one of the answers. So I'm going to move it to this first one right here. And once it's near it, I press enter, enter, enter. This is so embarrassing. You ready for it? Okay, hold on. This, right there, mark that out. That should be a minus. A big old typo. Lovely. That's why it didn't work. Okay, so if we try that again, this time with the actual correct equations, we're going to get a different looking graph. So I was wondering why my brain, I was like, that doesn't look familiar. My bad. My human was showing. If we graph it this time, how many solutions should I be finding? 1 solution. So we have a graph that looks like this and a graph that looks like that. We're looking for the one place where they cross, but the steps are still the same. Second, trace 5. Move the little turtle close to the place. You don't have to be perfect, just get it close. That's pretty good. Enter, enter, enter. Ah, much nicer. That point of intersection is the coordinate 2, 0. Yeah, my bad, typo. All right, so the next 2 are for you. I want you to prove to me that we know how to do this. I want you to find the solutions or the solution to number 3 and number 4. You got this. I'll give you 2 minutes. I think 2 minutes is plenty. I'm going to repeat the steps after finding that first one to find the second. Second, trace 5, and then I'm going to move the little turtle just down towards the other one, which, yes, I know it's all covering it up right here, but you know it's down there. So I'm going to press enter, enter, enter. And it gave me the other one. It crosses at -3, -11. So it does cross twice. This one's just a really narrow example. The ones I'll ask you about on your homework are all very obvious if they have two solutions. They're way more obvious than this. Okay, on the last one, this is a very interesting question. Because you have two quadratics, it could potentially cross 2 times. That's a nonlinear system. Oops, I know I'm writing them in the wrong order here, but you can do them in any order. Let me go back up. Oh, too far. Then we have -x squared minus 2x. If I graph that, do they cross? No. If they don't cross, how do we answer this question? No solution. Very good. Again, it's no solution because they don't cross at all. So finding nonlinear systems really, really super easy because it's just looking at a graph to decide where the lines cross. Now we love graphing these things, but we can also solve all of these by hand. And I'm going to ask you to follow along with me because it's going to review something from September. We're going to solve a nonlinear system by substitution. When you have a substitute teacher, your teacher is gone and is replaced by somebody else. So when we substitute something, we're going to let it be gone and we're going to replace it with something else. What I mean by that is, do you see how this equation starts with y and is equal to this quadratic? And the second one starts with y and is equal to a linear? Isn't y the same letter? Isn't y equal to y? Aren't y's the same thing as y's? Yeah, so we can replace those red and blue y's with the red and blue equation on each side. So this is going to say x squared plus 5x plus 5 equal to x plus 2. All I've done is replace the y's with their respective equations. I'm still on step 1. That's the substitute step. To simplify, what have I been doing with equations that look like this to make it set equal to something specific? What do I always try to set it equal to? 0, which means I'm going to take this x and I'm going to move it over here. When I move it over there, what happens to it? Becomes a negative. I can combine that negative with the 5x. So I'm going to subtract 1x over here. That would mean I have x squared plus 4x plus 5 equal to 2. I'm just doing this step by step. So I've just subtracted x to both sides. Is it set equal to 0 yet? No. No, so I got to move this 2 over, right? When it moves over, what happens? Negative. So it's going to combine with the 5, and it's going to make x squared plus 4x plus 3 equal to 0. The moment I have it set equal to 0, I can identify A, B, and C, and I can factor using my X puzzle. How do I set up this X puzzle? Let's review that for a second. What goes on top? A times C. So I'm going to multiply 1 times 3 and put it in the top. What's 1 times 3? Great. What number goes in the bottom? 4. B or 4. Now what number goes underneath my little fraction bars? 1, the A value. Very good. Okay, great. We've set it up. Do I make a list for the top number or for the bottom number? The top. Well, the only things that multiply to 3 are 1 times 3. It's a prime number. And if I add those numbers, what is it equal to?
4.
Amazing. These numbers are 1 and 3. If we simplify these down, this turns into the factored form x plus 1, x plus 3. Keep holding on. Maybe write smaller because we still got some ways to go. Once it's set equal to 0, we're just going to take each of those individual pieces and set them equal to 0. That's called the zero product property. You don't need to know that, but that's why we do that. Now, if we focus only on this guy right here, x plus 1 equal to 0, how do I solve for x? Subtract 1 from both sides. That means x is going to be equal to 0 minus 1, which is negative 1. If I focus on the second little equation, how do I solve for x? Minus 3 on both sides. This is going to be x equal to negative 3. Woo-wee! Feel like we've done a lot so far. But guess what? If we're looking to solve a system, remember we always found an x and a y coordinate to solve my system. What variables have I found? X and, did I find a y yet? No, so I have to find the y. But this part's really easy. What I'm going to do is I'm going to take the blue equation from the top of my paper that just said x plus 2, and I'm going to plug both of those x values in to that equation. I'm going to plug these numbers in right here. So I have one of them that says y is equal to negative 1 plus 2. What's negative 1 plus 2? 1. And the other equation would say negative 3 plus 2. What's negative 3 plus 2? Make it negative. Okay, now I have, I have an x and a y together, and I'm gonna do this because this x goes with this y, and this x goes with this y. I have my two places where this system will cross. They are the coordinates, negative 1, comma 1, and negative 3, comma negative 1. Those are the two places where this system would cross on a graph, but I found it by substitution. That was a lot of math we just did. Whoa. First, we substituted and simplified. We set it equal to 0. Then we factored and we solved for x. Once we solved for x, we just needed to plug it back into the equations to solve for y. These are pretty gnarly problems. But each of the steps is something we know how to do. It's just putting it all together, doing it by hand, that's a little difficult. Most likely, you're going to choose to graph these systems instead of solving them by hand, because this is all that's required to solve it by hand, when in the calculator, you just press second trace 5, enter, enter, enter. Like we're going to use the calculator, correct? We have that technological tool. We're probably going to use it. Speaking of that technological tool, we're going to super use it on number 6. Number 6 is a real-world scenario here. It says the graph shows the height in feet of a soccer ball certain seconds after it is kicked from the base of a hill with initial velocity of 20 feet per second. The linear function represents a hill with a constant slope. So if you look at what they've given us here, this is the soccer ball. What is this? What is this line right here? Look, I'm making it look like an actual thing. It's the hill. Yeah, it represents the hill. So we're going to figure out how many seconds does the soccer ball land on the hill. We are looking for this point right here. What is that coordinate point called? Starts with an I. The intersection. But the way that we'd been learning how to find the intersection on the front page is by having two equations to type in and just seeing where they cross. So we've got some work ahead of us. What we are going to do is we are going to write a regression equation for a quadratic. We are going to write a regression equation for a linear, and then we're going to see where they cross. So what I mean is we're going to find the equation for this guy, and we're going to find the equation for this guy, and then we're going to figure out where they cross. So let's do it piece by piece. That first equation is a quadratic. I require 3 numbers to find a quadratic. I have 1, I have 2. Can anybody find me a third coordinate point to use for this quadratic that's nice and pretty and neat? 0, 0 already works. Yeah, we got 0, 0.
1 and 4.
1, 4. Does 1, 4 work? Oh, wait. Yeah, 1, 4 is right here. Yeah, check. Got that one. What else? 2, 2. 2, 2. Is that what you mean? Is that part of the red graph? Does it point at the red graph? No. So we need a different. It's not listed there. It's not on. You're going to have to find it. I need a perfect coordinate point. 0.5, and is that perfect? It kind of looks off to me. What about this one right here?
4, 1.
Well, what is this coordinate point right here? 0.25, comma, what? Comma 4. We had to find a nice, pretty point to be able to use it. It has to be absolutely going through that little corner piece, a perfect point. Once we have the 3, we're going to go to our calculators again, and we're going to use stat edit to do this. Now, we went over these steps last class. When we do stat edit for quadratics, we choose option 5, which literally says quadratic regression. So let's go through those steps again together. To do this, I'm going to have to cover this up, so make sure you have that point written on your paper. To do this, we're going to go to stat, and we're going to go to edit. You're going to follow along with me as we do this. If you have stuff typed in there, you're just going to delete it all out. Don't delete the list, just delete the numbers. The numbers we have are 0, 0.25, and 1 for our x's. For our y's, we have 0, 4, and 4. Those are all the coordinates we found off of the graph. I'll give you a second to catch up on typing. In, what we're going to do is press stat one more time. We're going to go over to calculate. And which option are we choosing? 5. We're writing a quadratic, so we're going to choose option 5. We go down to store regression equation. Does anyone remember the buttons we pressed there? Alpha, trace, enter. You must do this time. If you skip this step, you will not be able to answer this question.
Wait, do it again. What did you say?
Alpha, trace, enter. It puts a Y1 right there. What it has done is it has typed your equation into Y1 for you. So this equation we got out of our calculator, y equal to negative 16x squared plus 20x, is already going to be typed into your Y1. Check this out. Negative 16, I know it's got a bunch of 9s behind it, it's because it's rounding the number. X squared plus 20. Incredible. We go to the second one and clear that out. We want to now find the regression for that linear equation. Linear equations only require 2 points to be able to write them. So what we're going to do is use the first origin point, because this graph also crosses through there, and we're going to go to stat edit and not choose option 5 this time. For a linear equation, which option do I choose? 4, because it literally says linear regression. Great, so let's do that one. We go back to our calculator. We delete out the stat edit tables we have. I don't want those anymore. I want to write new ones. So I delete all of the numbers. Don't get ahead of me because you're going to mess up. Listen to what I'm saying on this one. We have 0, we have 2, we have 0, we have 2. Oops, typo. I'm going to press stat, and again, don't get ahead of me, please. Stat, calc, and which option? 4. But this time, when I go down to store regression equation, we have already stored one of our numbers in this system in Y1. Do we want to store another one on top of it in Y1? No, we want to store it in the next one. So when I press alpha trace, I don't want to pick Y1. What should I pick? Y2. Because now it types it into Y2 and you'll have a full system graphed on your screen. My equation here is good to have it, 1x plus 0. But now that I put one number in Y1 and one number in Y2, look, it already typed it in for me. Incredible. If I press graph, I get a visual of the same thing from the soccer kick table here in my calculator. How did we find a little bit ago the intersection point between the curve and the line? Second, trace, 5. Now I'm going to move the turtle, not for the first one, but to that second one, because we want to know when the ball lands. So I'm going to try to get it close to that second equation, or second place it crosses. I press enter, enter, enter. My intersection point is the coordinate point 1.1875, comma 1.1875. That's the place where these two lines cross. Now I know on your homework it's going to ask you to round to the nearest tenth. How many decimals is tenth? Ooh, no, that's hundredth. How many decimals is tenth? 1 decimal, 1 after the decimal. So if we were going to round this number, for how many seconds does the soccer ball take? How would we round the how many seconds number, the x number, to 1 decimal? 1.2 seconds. That's what we found to be where this line crosses. Now the second question here says, check the reasonableness of this solution. Based on the graph here, is it reasonable for the time to be 1.2? Look at the numbers at the bottom of the graph. Yeah, this is 1, and this is 1.5, and it's about here. That's the right amount of time for a ball to be up in the air, 1.2. So our reasonableness of the graph checks out. So we would say, yes, it's okay. That's reasonable. That's a reasonable amount of time for a soccer ball to be kicked up in the air. As long as you're not good at soccer like me, that's actually pretty impressive to have the ball go up in the air. 1.2 seconds. I probably couldn't get it up in the air. So as long as it looks okay for the graph that you have, you probably have a reasonable solution. If you're like, Ms. Quigley, that was a whole lot of things that we had to do for this question. You're right. I have the steps written here. Use stat edit on a calculator to write the regression equations, or if you don't have a calculator, you can use Desmos. You'll need 2 points for a line and 3 points for a parabola, and then follow the previous calculator steps to graph the equations and find the intersection. If you want a little bit extra, that's second, trace, 5, and then enter 3 times. So today, because we use so much of the calculator to be able to do these problems, I'm going to give you a lot of class time now to work on the assignment for today. I would love for you to finish it right now. That way you have the rest of the class period to work on the missing work in the progress report that I gave you. Yes, this is not optional work time. Everybody will be working on this assignment and only this assignment right now.